was too late.
There's pollution all over the world, but that means there's a lot of solutions. Pollution solutions, and we can all work together to be part of them. Come on, lend a hand, pitch in. We'll clean this whole planet up. It'll be fabulous. It's an exciting time to be alive. We can all work together to clean up a whole planet. Woo! Ha! See? That's the way.
Actually, I think it's 2 blocks farther down there.
The environment.
This is paper or plastic?
On the paper side, I'm dioxin.
And on the plastic side, I'm polypropylene. Let's get right to it. Dye, you fibrous bag. Are you aware that plastic is much more durable and therefore much more desirable as a container for groceries? Durability equals more reusability. End of discussion.
Excuse me, Miss Plastic Personality, but paper is much easier to recycle, and it isn't filled with toxins like benzene and even the more dreaded polypropylene.
There's no need to get personal here, you chlorine bleached twine.
Who are you calling a chlorine bleached twine? Why, you little let off!
Next week, cloth, a better solution.
This is a thermostat. It's an electric switch that controls the laboratory furnace. It keeps the lab at about the same temperature all day. Most houses in North America have thermostats because we need to heat our houses during the wintertime. Take a look at this. It's our cityscape thermometer model of science. And imagine there's a thermostat in each one of these houses. And the temperature of the house is shown on these giant thermometers. Now suppose that everybody turned their thermostats down just a little bit, just a couple of degrees Celsius. Well then, everybody will save a little bit of energy, right? And the houses will be just a little bit cooler. You could probably keep warm just by wearing a lab coat. Anyway, each house will save a little bit of energy, but all the houses together will save a lot of energy. The level of this liquid represents the fuel or the energy that we'd save if everybody turned their thermostats down just a little bit. See, it's a huge amount of energy. Every house in North America, every thermostat, I mean, that's a lot of energy. And when you save energy, you make less pollution because you're not burning fuel or coal, natural gas or oil. See, and on top of that, when you use less energy, you spend less money. It's a triple threat. You know, less energy, less pollution, less money. Used to say, great. Down to 20 and full model.
Some trash is biodegradable, which means it rots or decomposes when left outside and eventually becomes part of the earth. But a lot of our trash just sits there. So here's an experiment that you can do to find out what's biodegradable and what's not. All you need is 6 clear jars, some labels, a pen, and some water. Now, collect some trash from around the house, whatever you and your family throw away every day. Fill each jar half the way full with water. Then toss a piece of trash in each one. Next, you label your jars and put them someplace sunny and wait a few days. You can see what happened. Some changed and some didn't. That's because plant and animal products are biodegradable and safe to throw away. But things like plastic and aluminum can't rot, can stay around for hundreds of years. So next time you go to buy something, think, is it biodegradable or not?
What's in this vial is a pollution solution. This is plastic extracted from plants. This plastic is made from petroleum and it's not renewable. And furthermore, it's not biodegradable. That is, if we throw this into a dump, it'll be there hundreds of years from now. My research is concerned with making plastics that are renewable and are biodegradable. This is ground up plastic, but we can melt this and cast it into shapes, and this is a little piece of plastic we made in the lab. Not commercial quality, but this is lab plastic. This is biodegradable. If I just threw it on the ground, this would be gone in about 3 weeks. these plants are making the plastic basically from sunlight and water and air. I think eventually we'll replace petroleum-derived plastics with plastics made from plants.
Bill. Oh, there you are.
Plastic is great. It's strong, it's durable, but here's the thing. It doesn't break down. So it ends up in an ocean or a lake. It just sits there till it washes up on shore or some animal eats it. And that's bad. That's really bad. Every year, thousands and thousands of animals die from the plastic we throw away.
Plastic isn't the only kind of pollution that's hard on things that live in the water. You know, some factories belch chemicals that end up in the sky. Chemicals like sulfur and nitrogen that form sulfuric acid and nitric acid, and that makes acid rain. When the rain comes down, the acid gets in the water, and that can be very hard on fish and the food that fish eat. Yeah. Pretty soon, you wouldn't need a fishing pole around here, for crying out loud. So I'll tell you what I'm going to do. I'm going to clean this place up. I'm going to pick up the trash.
Where's your soapbox,
One piece
Bill?
at a time. That's what I'm gonna do.
Bill?
See, the trash all got here one piece at a time, so I'm gonna pick it up one piece at a time. Is that okay? It's not just the foam, it's not the plastic, it's all of it together. It's hard on living things. Everybody picks up one piece at a time. The place eventually is gonna be clean. Okay?
Science Guy wants you to keep our planet clean.
Well, that's our show. Thanks for watching. You'll excuse me. I've got some high-grade copper wire to recycle. I seem to be caught here.
Bill. Now you've done it. Bill,
A little tangled as well.
don't panic, Bill. Stay calm. Okay, now you can panic. No actual science guys were harmed in the production of this program.
Produced in association with the National Science Foundation.
Pollution solution number 349.
Put a container full of water in your toilet. This simple pollution solution can save up to a half a liter of water per flush. That can add up to hundreds of liters a week. And saving water means saving energy. And that means less pollution! So what are you waiting for?